Welcome back everyone, Patrick here. Moving on to the next question. We have to take each of these and factor them by grouping. So this is a new factoring type of technique that we're going to go over, and it's a fairly popular one. It's actually very similar to the previous one that we just did where we had to factor out binomial common factors. It's just there's going to be a preliminary step now. So just as a quick review of the last video, what we were factoring was stuff like this, for example. Right? We were given this kind of format, and then we noticed that we had a binomial. In this case, it's x plus 5 that was common in both of these expressions, so we could take out that binomial common factor, and then we'd be left with the x minus 3. Well, what's going to happen in this case is we want to try to take these and put them in this format. So then we could clearly see what that binomial common factor is going to be. Because if you think about it here, if we expand everything, so if we had x squared plus 5x minus 3x minus 15 like that, what we can do is these two, we could take out an x, and then from these two, we could take out a negative 3, and then we end up with that binomial common factor. So that's basically what we're doing. In the previous video, we were given this expression, and we were able to go to here. Well, now in this video, what's going to be happening is we're going to be given an expression like this, and we have to go to here and then go to here. So there's just going to be that one extra step at the beginning. So that's the process here, as you can see. What you do is from these first two, you take out a common factor. Then from these two, you take out a common factor. And then if you have the same bracket here, which is what should happen, it's actually a nice way to check your work in the middle of the work. You should get the same brackets here. You could take that out, and then you end up with that other factor. All right, so following that process, let's start off with part A. So we got ax plus ay plus 5x plus 5y. Now, one thing I want to mention here, with any kind of factoring, what I always look for is, can I first factor something out of all of the expressions before going over any technique? And that's not going to be possible in part A and B, but in part C, you're going to see it's possible. In part C, there's going to be two ways to do it, because notice that from all of these expressions, we can actually take out a 2. Okay, but in this case, we have a's over here, but there's no a's over here. We have 5's over here, but there's no multiples of 5 over here. We have an x here, but no x over here. We have a y here, no x here, etc., etc. There's nothing that we could take initially out. So that's the first thing that I personally check for. So from here, we can't do that. So now we can go into that factoring by grouping. So notice from these first two, what can we take out? We could take out an a. An a is common in both of these. So what would we be left with? X plus y, right? Remember, what's left in the bracket is if we take whatever we take out, we just divide the expressions by what we took out. Notice the a's would cancel out. We'd just be left with an x plus y there. And then over here, we have plus 5x plus 5y. Well, from these two, what can we take out? We could take out a 5, and we'd be left with x plus y, like that. And now notice we're in that same format like the previous video, where now we have a binomial common factor. We could take that out, and we'd be left with a plus 5. Okay, so that's just the general process for all of these. Now, sometimes there's going to be certain tricks involved, and there's going to be a couple in this video that I'm going to show you. But in general, that is what is happening. Okay, so let's move on to part B. We got x squared plus 4x plus 6x plus 24. Now, first off, notice we can't take anything initially out. There's no greatest common factor here because we have x, 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 but there's no x over here that we could take out. And then notice that between 1, 4, 6, and 24, there's no common factor there just because of this 1 over here. right? So there's nothing we can initially do. So now let's go into that methodology for factoring by grouping. We would factor out of these first two. What can we take out of these two? We could take out an x. So we'd be left with x plus 4. And then from these two, we could take out a 6. And we'd be left with x plus 4, like that. Right? This x plus 4 comes from dividing this by x, dividing this by x. This x plus 4 comes from, because we took out a 6 from these two, dividing by 6, dividing by 6. And now notice we got a binomial common factor. So it would be x plus 4. We take that out and we're left with an x plus 6, like that. So that's what it factors to. So that's the answer to part B. Part C, so this is the unique one because we're going to be able to take something out. And there's actually a couple of ways to do this over here. So notice in this case, it's actually very similar to part B, except now instead of a 1 over here, we have a 2. Notice we have to go 2, 4, 6, and 12. Common factor between all those is 2. An x variable we can't take out because this 12 doesn't contain an x variable. So a couple of things we could do. We can go into factoring by grouping right away from here if we want. And if we did that, what would happen is from these two, notice we could take out a 2x, right? Because 2 and 4 have a greatest common factor of 2, and then x squared and x, we take out the one with the lowest exponent, which is x to the power of 1. And so what would we be left with? Well, if we divide this by 2x, notice the 2's cancel out. X squared divided by x to the power 1 is just x. Divide this by 2x, the x's cancel out. 4 divided by 2 is 2. Then from these two, we got a 6x plus 12. An x variable we can't take out, but we could definitely take out a 6. And if we take out a 6, what would we be left with? The 6's cancel out. We're just left with an x. And then 12 divided by 6 gives us 2. And so from here, we could take out an x plus 2. And we'd be left with 2x plus 6. But notice here, we're still not fully done yet, because from this bracket, we could take out a 2, right? There's a 2 that's common in the 2x and 6. So if we take out that 2, let's put it in front. Once we take out the 2, divide this by 2, divide this by 2, we're left with an x plus 3, right? 2 times x plus 3 is the same as 2x plus 6. So that ends up being the final answer. So that's one way to go about it if you got into the factoring of by grouping right away. Now, what if instead of doing that, we first initially took out that 2? So if we first factor out that 2, what would we be left with? Well, we would just be dividing everything by 2. So we'd have x squared plus 2x plus 3x plus 6, like that, right? Just taking out a 2 from all of those, we're left with this. And then what you could do is you could do factoring by grouping on this remaining bracket, and then just keep that 2 on the outside. So notice if we do that, let's just work with this bracket. Let's remember that we got that 2 on the outside, so I'm just going to be working with this right here. So from these two, we could take out an x. We're left with x plus 2. From these two, we could take out a 3. And we're left with x plus 2. And then notice we could take out that x plus 2, and we're left with x plus 3. So that's what this square bracket factors to, but then we got that 2. And if we look at the whole thing, we got that 2 in front still, right? So that 2 kept on carrying over. And so we end up with that same solution. Okay, so 2 different ways to go about it. My preferred method is to take anything out initially, and then whatever's remaining, then we can go into factoring by grouping or what other methodology. We're going to be going over a bunch of different methods of factoring. In this particular video, we're just doing grouping. So if I could take something out initially, that's what I do. I take it out initially, and then I go through the process. Okay, let's move on to part D. So we got mx squared plus 3 mx minus 5x minus 15, like that. So from here, can we take anything out initially? Well, there's like a 1 in front here. 1, 3, 5, 15. No, there's no common factor between those. We have an m here, we have an m here, but notice we don't have an m in those expressions. We have an x here, an x here, an x there, but there's no x in that expression. Okay, so there's nothing we could initially take out from everything. So from here, let's go into the factoring by grouping. Factoring by grouping, we look at the first two. Okay, forget about those. What can we take out of both of these? Well, we could definitely take out an m, right? M to the power 1 is common in both. And then we have an x to the 2 and x to the 1 over here. So x is common in both, and we take out the lowest exponent, which is x to the power 1, right? 1 is the lowest exponent between 1 and 2. If this was 2 and this was 3, then we'd be taking out an x to the power 2. But we got 2 and 1, take out the lowest exponent, and then between 1 and 3, there's no factor there. So mx in this particular case is the common factor between these two. So what's left in the bracket with this particular one, you may want to divide on the side, right? Sometimes if these get a little bit more complex with all these different variables, it could start getting a little taxing mentally to try to do it in your head. So just take the time to just divide out to see what's left. Notice the m's cancel. And then we got x to the 2 over x to the power of 1. So we subtract those exponents and we'd be left with x to the power 1. So that's what would be left over here. Then we have a plus. Then we got the 3mx. Divide that by mx. The m's cancel out, the x's cancel out. So we're just left with a 3. Okay, and if you want to check your factoring at this step, you could just redistribute that mx in the bracket and make sure you get those two factors. Notice if we do that, mx times x would give us mx squared, mx times 3 would give us 3mx. Okay, so that is correct. And notice it is the greatest common factor because we can't factor anything else out of there. That's another check that you can do, and I went through that in a previous video when we were taking out greatest common factors. So notice that x plus 3 can't factor anything further there. Now between negative 5x and minus 15, whenever there's a negative over here, you're usually taking out a negative value. Okay, so in this case, you kind of want to ignore this negative and just look at the 5 and the 15. What's common in both of those? Well, a common factor is 5. So we could take out a 5, but then we got this negative in front here. So what would we be left with? Let's just actually write it over here. Okay, sometimes it, especially maybe when you're starting out, it might be worth it to take both of these expressions separately, write them out on the side over here. Okay, so you're not getting too mixed up in the whole scenario. So just factor this and then factor this. You could treat it as two different questions and then you could combine it in your work. So here we got negative 5x minus 15. What you want to do is take out a negative 5. And if I take out a negative 5 from these, if I divide this by negative 5, notice we're just left with an x. If I divide this by negative 5, negative 15 divided by negative 5 would give us positive 3. So we're left with x plus 3. So the reason why you want to take out a negative 5 over here is so we can get the same bracket. Remember, we got to have the same bracket here. If you don't end up having the same bracket, either one of two cases. Either it's not possible to do the factoring by grouping, because not all expressions can be factored by grouping, or there's some kind of mistake that you did. So if we didn't take out a negative 5, let's say we took out a positive 5 over here. What would happen? Well, we'd be left with negative x minus 3. But then negative x minus 3 is not the same as x plus 3. So then we can't take out that binomial common factor in the next step. That's why we got to take out a negative 5 here in order to have x plus 3 in this bracket, in order for these brackets to be the same. And now we could take out that bracket and we're left with here mx minus 5, like that. All right, so that's what part D factors to. Okay, so just be careful with these negative expressions over here. So this would be x plus 3 and then mx minus 5. Moving on to part E, we got 9x squared minus 12x minus 3x plus 4. So in this particular case, again, check, can we take anything out? We got 9, 12, and 3. Common factor between those is 3, but then we got the 4 over here. Okay, and 3 isn't a factor of 4. So can't take out anything in terms of the integers x, 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 but then there's no x over here. Okay, so we can't initially take something else. So if we go into the factoring by grouping, 9x squared minus 12x, let's just look at these. Let's do it on the side over here. Okay, what would be the greatest common factor here? Between 9 and 12, it's 3. And between x squared and x to the power 1 is x, right? The lowest exponent. What would we be left with? Divide this by 3x. 9 divided by 3 is 3. X to the 2 over x to the 1 is x. Minus, over here, take out 3x. X's cancel. 12 divided by 3 is 4. Okay, so these first two, let's write it over here actually, they factor into that, like that. And then we got minus 3x plus 4. So this one's interesting because notice in this case, can't between 3 and 4, no common factors, and then there's an x here and not an x there. So can't take anything out in this case, but we do need to have that same bracket. So notice there's a negative here. What we can do is if we can't take anything out, there's a negative here, we take out a negative 1. This is another kind of special case that happens a lot of times where there's no common factor between these two. Take out a negative 1, and so we divide this by negative 1, divide this by negative 1, basically all the signs change. Right? That negative 3x changes to positive 3x, that positive 4 changes to negative 4, and now notice we got the same bracket. So we'd have 3x minus 4 that we could take out, and we'd be left with 3x minus 1, like that. So that ends up being the solution. Another thing I want to mention with this one is, and not just this one, sometimes it might be in different orders. Okay, so for example, let's say we switched up this negative 12x and negative 3x, so we'd have 9x squared minus 3x minus 12x plus 4, like that. From these two, notice we could take out a 3x, so we'd be left with 3x minus 1. And then from these two, we could take out a negative 4, because there's a negative here, so that's what we got to factor out, a negative 4. What would we be left with? 12x divided by, or negative 12x divided by negative 4 would give us positive 3x. Positive 4 divided by negative 4 would give us negative 1. And then we could take out a 3x minus 1, and we're left with a 3x minus 4, like that. And notice that's the exact same thing that we got over here. So sometimes it could be in different orders. That's the first thing. And then the next thing I want to mention is sometimes you have to rearrange it. So let's say that we were given this in this particular order. Let's put the 9x squared and the 4 together, and then we'll have minus 3x minus 12x, like that. In this particular case, factoring by grouping right away is not going to work, because from these two, can't take anything out, even if we took out just the 1. Then from these two, we could take out a minus 3, but then we're left with x plus 4. Notice that this bracket, that bracket aren't the same. So in this particular case, factoring by grouping wouldn't work, so you'd have to rearrange it. Okay, sometimes it's a bit of trial and error, so you got to be careful with stuff like that as well, because this is the exact same thing as this or this. right? And we know that both of these factor. So we know this definitely does factor into that. It's just we got to rearrange it, bring the negative 3x over here to get it in this format, bring the negative 12x over, or put it in this format. Okay, so sometimes you got to, if something doesn't work initially, rearrange some stuff, right? Then try it, and a lot of times it will work. In this case, we didn't have to rearrange anything, it just worked right away, but sometimes you will have to rearrange stuff. Okay, it doesn't mean that it's not going to work, so just be on the lookout for that as well. All right, so that's what the answer is for part E. And then finally, part F. First off, can we take anything out initially? 3, 3, 2, 2. No. We have an M here. There's no M here, so can't do that. We have an X, 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 but no X over here. Then we have a Y, 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 no Y over here. We have an N, but no N over here. So there's nothing that's common in all of the factors. Okay, so now we can go into the factoring by grouping. Let's look at these two first. So notice we could take out a 3. M, N, those are different. Can't do anything with that. Notice we have an X and X, so we could take out an X squared. And I think that's the only thing we could take out, right? We have a Y here, but no Y over here. So 3x squared is the greatest common factor between those two. So what's left? Let's do it on the side. There's a lot going on here. 3's cancel out. There's an M. X to the power 3 over x to the power 2 is x to the power 1. So mx is left plus 3nx squared y divided by 3x squared. 3's cancel out. The x squareds cancel out. Notice we're just left with an ny right there. Okay, so, and then from here, can't take anything out as a final check. Then from here, we got negative 2mxy squared minus 2ny to the power 3. Notice we could definitely take out a minus 2. And because it's minus, that's how we know we got to take out a minus. M, no m there. X, no x here, but we got a y and a y. So y is common. Take out the lowest exponent, which is y to the power 2. So what would we be left with? Because we're taking out a negative, let's include the signs here just to not get mixed up. Negative 2's cancel out. The y to the 2's cancel out. We're just left with mx. And then we got negative 2n y to the 3 over negative 2y squared. These cancel out. We have an n left. Y to the 3 over y to the 2 would give us y to the 1. And it's positive, right? Because we took out a negative. So basically the signs are changing. This changes to a positive. This changes to a positive. Okay, if you're a little unsure with factoring out negatives and stuff, I recommend maybe going back to the greatest common factors video, going through that. But you should be fairly comfortable with what I am doing here, right? Knowing how to go from here to here, here to here. You may have to watch it a couple of times, but hopefully you're getting it. And then here, notice the brackets are the same. All right, so this one's fairly complex. There's a lot of variables going on, and we're left with a 3x squared minus 2y squared like that. Okay, and then those do not factor any further. So that would be the solution to part F. Right, so with all of these, first thing I check for, can I take anything out of all of the expressions? Sometimes you will, like in, I think it was part C, we took out a 2, and then you could do the factoring by grouping, but if you can't, then you just go straight into the factoring by grouping. And also be on the lookout, sometimes you may have to rearrange things and put them in a certain order in order to be able to do the process.